And we're back with another live stream. Good evening, good evening, good evening. Oh dear. That's like that's from, what's it called? QI. Shh, don't tell the BBC. Yes, welcome back everyone to another Vector 3D live stream where we're taking a look at the Ratrig V Core 3. This is live stream number 7. And we've done most of the mechanical assembly, but we have to start off with correcting some of the things that we missed out last time because I acquired the incorrect extruder. So there's a little printed adapter which we have to fix. After that, I'm not entirely sure what we're going to get on with. There's a whole bunch of stuff that we need to do, and we're just going to give it a go. Yes, that's the plan. It's Mr. 3D. That's the name. I quite like that, isn't it? It's quite good, that, Mr. 3D. Very clever. Evening, Simon, Bombdale, Turan Gaming, and Johnny Bergdahl. And anyone else that's watching. 36 people. Right. Yes, what is this then? So, as I said, we got to correct the thing that I messed up last time because of the wrong extruder. That's definitely the first thing. So we've got to get the printer over here. We're going to get that down. Another thing we can do is work on the panel. So the panel that goes between like the main printing area and the electronics, and that's for mounting the electronics. Need to work on that. What's another thing we have to do? The configuration of the Duet. So I did a poll on YouTube, Twitter, and in Discord as well. My name is 3D, Vector 3D. I like it. So yeah, I did a quick poll to see who was interested in configuration, and the overwhelming majority wanted to see basically everything for that. So yes, we'll be doing everything. So anyone that's not looked at RepRap firmware before or a Duet board is going to have lots of information to go off. We also have a load of wiring to do. I don't know how much people want to see crimping, but I'll try and provide some information on crimping and cable lengths, wire lengths and stuff like that, because we've got to set up a lot of that stuff. That can take an awfully huge amount of time, and it's probably not particularly entertaining to watch. Joshua, holy hell, thank you very much. $20 donations, very kind of you. Vector 2D is kind of shallow. Oh, that's terrible and also amazing. Stephen the Lightspeed. I bought the 500 by 500. I got the Magnum Plus. Ooh, I haven't seen, well, I haven't used a Magnum Plus, obviously. They're pretty big. What's their flow rate compared to the Magnum on that? I wonder if is it significantly higher. Oh, everyone wants to see all the wiring as well. Well, Russell wants to see all the wiring. I don't know if I want to do all the wiring. It's so boring to do. Normally I like to kind of watch stuff at the same time because it's a very tedious process. We'll see. Let's just get going for now, and we'll catch up with more things when we get there. Anyone that wants to leave a like, that would be very much appreciated. And also, if you haven't subscribed and you're already here at the start, chances are this is probably the kind of thing for you. So you may want to hit subscribe so you don't miss out anything in the future. So let's get going. I also have some other parts to introduce as part of the wire management and stuff. I've forgotten, after the week of not having to lift this, I've forgotten quite how heavy it is. Has it been a week? It feels like a week. Can I lift this to the desk without hurting myself? Sorry, microphones are all over the place. Sorry. Hadn't set that up properly. I do apologise. Hopefully that sounds a bit better than it did just now. YouTube wants me to lower the bit rate because I changed it. Pavel is here. Your daughter is watching with me. She does not believe it's live. Can I get a hi, Leneka? Oh my god, I'm so sorry. Lenka? Hello, Lenka. This is definitely live. It's so live that I probably pronounced your name wrong and do apologise for that. And you probably couldn't see me either. Hi, Lenka. It's definitely live. Andrew got home in time, just in time for the series. Good to see you. Totally live. There you go. Mikhail's here too. We've got everyone. It'll probably be a bit loud at the beginning until I stop shouting. She ran off the brag. Cool. Rightio. Let's. What are we doing? Yes. This tube. So let's get our camera angles sorted so we can make sure everyone can see what's going on. First, we'll raise this one up a touch. I think that should give you a view from there. We can move this one to get something close from this side. And the one over the top is going to be over the top. So before we get started with actually doing any of the actual work, we're going to have a very quick message from the sponsors of today's video, today's live stream, which is RapRig, Duet 3 and 3D Printz. So this is just a 15-second message, and then we shall be back to carry on with the work. This live stream would not have been possible without our sponsors, RapRig, Duet 3D and 3D Printz. So a big thank you to them for supporting the live stream. Carry on watching to find out more, or you can follow the links in the video description. It goes really creepily dark after that sponsor message, doesn't it? Anyway, so instructions wise, oh, I can't scroll this page down. I can do this. So since last time, the spool holder instruction has now materialized. So we could do that, but I'm going to probably leave that till, because we don't need it on there at the moment, so I'll probably assemble that later on. It looks like a really simple assembly, so hopefully no one is urgent for help with that. Of course, we were doing the ever, that's the one, ever assembly last time, and because I have the Magnum version, the Mosquito version of the Bondtech, so the BMG-M, you have to have a little adapter, and I didn't have it, so I printed it out, which we had at the end of last time, but didn't fit it. So going to start off by doing a bit of disassembly in order to get that in, because this is the tube that should be basically in here between that and that. So we need to do that. So that's the first thing. So glad I managed to squeeze this in, as in a live stream this evening. After not doing it for a little bit, I just get an itch to build stuff. Eva. That's going to get creepy if I start doing weird voices. Probably try and avoid that. Eva. Okay, so we need to take the shroud off at the front. I think to take the shroud off we need to take the BLT, the bacon, lettuce and tomato. That needs to come off. Obviously I'm not really following instructions for this, I'm trying to just take off things that I sort of remember from the assembly process. So hopefully that will come off. Nope. Okay, that's the Bondtech assembly off. So we need to add this adapter to the base of here. Okay, so there are a couple of screws that we need. Oh, knocked over the water bottle. I'm just going to go back to the point on the street, the point in the instructions. Oh, it looks like I'm about here, where we install it. Oh, there was an extra bit, wasn't there? I can't remember if they're 10mm, because there were, I think there were two sets of the M2 screws, or M2.5. Let's see what we find. M3, 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 M2.5, 10, and 2.5, 12. Can anyone remember if we need the 10mm ones or the 12mm ones? Oh, they look different sizes. Those look like M3. Let's hope it's the 10mm ones, because the M2.5 by 12 look like M3. Orders? No, these are M2. Let's have a look. Let's see what fits. Okay, those don't fit. The bag marked 2.510 are M2 screws, so this one is going to be one of those days. These screws, M2, you can see, maybe if I hold them next to each other, both labelled the same. They're quite clearly different sizes. Well, they're not labelled the same, as in one's labelled 10, the other's 12, but they're both M2.5. So I'm going to go try the M2.5 by 12. Hopefully that's going to be fine. The question, is there any reason you use the BMG and not the LGX? Because I'm building the default configuration, that's the main reason. So, because I'm obviously going to be reviewing this, it's useful to have like a standard baseline. So that's what I'm going off of. Oops, I need a different. Because obviously it's a very configurable machine, it's difficult to objectively review something that could be very different for someone else. So I'm reviewing a specific configuration, which is the default configuration, which will be sold as a configuration basically for people who are not sure if they want to do A or B or how to make the right decision or anything like that. So this is a config for anyone that's not too sure. There we go. So that basically holds that tube, the feed tube, come on, in place. Just in the end there. Don't know why this is not going together. There we go. So, excuse me, not sure quite how I'm going to get this. This looks way too long, isn't it? I'm guessing this tube doesn't need to be as long, does it? I'm guessing it needs to be shorter because of the, I think that BMG-M is going to be slightly different. Okay, thanks, Pavan. Do you know, can you remember, would you be able to kindly let me know what length it should be so I can cut it and measure it as appropriate? Please. Save me rummaging through the instructions. Thank you very much. So let's just stick this down here quick. So my favourite way for cutting PTFE tubes is to have a jig, which is basically like a piece that helps you cut things without having to measure. So it's more of a gauge that will measure a set length and nothing else. So they're really great for cutting things the same again and again and again. Whereas in this case, it's just not by eye. We're obviously going to be using a ruler, but it's not going to be super precise. Although, to be fair, on the first cut I did get it within, what was it, within 0.2 millimeters. So not bad. We just need to, when we know how long it needs to be, we can cut that down. So the question is, what are we going to work on next? Because there's obviously a lot that we could do. I'm just not sure what to do. If anyone has any specific requests for what we should do next. Obviously it's not going to be printing. There's lots of setup still to do. What else do we need to do? I reckon the Duet configuration could be a good thing to do today. That maybe takes half an hour to an hour with a bit of explaining. Probably not going to go, I'll go through a method. I'm not going to go through every single method of how to do it, because I think it's probably a little bit much. The back panel, obviously, so the back panel is designed to go in during the main assembly. So there's a step that specifically says, put the back panel in now, because it's going to be difficult to do it later. And I think it would actually be impossible to do it at this point. So what I'm going to do is cut that panel. So I'm not sure, if I cut it along horizontally, I can sort of put the top half in and then the bottom half and screw them all in. Or I can do like an S shape down the middle. So I can put the left side in and then the right side in, and they all screw down the middle. I think the S shape would be better because it means you get screws around the edge of every side of that panel. Whereas if you do it horizontally, there's going to be a bit, like that horizontal cut won't have any screws on both sides of it. So that could be just a way for vibration to carry. You'd end up with it being able to move so much, be like a drum face or something. So that wouldn't be ideal. Let's see if I can find a different length for this BMG tube. Ba, 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 ba. .8 millimeters, more or less. Okay, 40.8. I can do 40.8 with nothing but this and that. That's 40.8. Let's double check. I'd say that's pretty good. That, ladies and gentlemen, is 40.8. Yeah, cool. I reckon that'll do. We may have to adjust it a little bit because, as we've just learnt, the position of these two parts can vary a little bit. We'll see how we get on with this. Here it is. Almost forgot to bring the camera up. How am I doing this wrong? How do I do that? I think what I need to do is put this over this, and then this over this onto this. This feels impossible. I might have to take the front off too. Using this V6 bracket. Oh, while we're here, because I've just remembered, I'm also going to, I think, put these wires in the other side of the heater. So, lots of backpedaling today. So, that one's too big for that. Okie dokie. Sorry, went a bit quiet there while doing that. My brain was thinking. So hopefully now those wires are nicely going to come out the other end while keeping the block. Have I rotated? No, that's supposed to be that way, isn't it? So that's good. That needs to slip in behind there. So I think now we're going to have to put the Bondtech motor in here, this plate on here, this over here, pull this out here. This is going to be all thumbs and fingers, this is. Oop. There we go. Oh. Why can I not get this to go in? Doesn't seem right. There we go. So that's good. That's tight on the top. Lovely, lovely. Now I can let this go in here. Oh, the BMG does not spin freely. So why is that then, eh? It does feel a little bit weird. The alignment doesn't seem quite right. I can see the brass gear poking out the back side, so I think that feels good. I think it's just getting the relationship right between the stepper motor and that gear. Because obviously if they're jammed up against each other, it's going to, excuse me, downside of doing this right after dinner. If they're jammed up right against each other really tight, then it's just going to make a whole load of friction in the gears, isn't it? So you want a tiny bit of space so as they rotate, they just roll through each other. Can you adjust it out of this door? It feels non-concentric. So there's like a smooth bit. Here's smooth. If I go around here, there's rough. And then smooth and easy, and then thick and rough. Am I just doing it too tight or something? Nope. My compliments my shiny nails. Thank you very much. I'm not sure how I achieved shiny nails. You know what? You'd actually be amazed how many people have commented on my nails. It's not normally a compliment, but it's a lot of people do look, because obviously the camera's like really close into my hands a lot of the time, especially when I do some B-roll on products and stuff. Some people can be very critical of what my nails look like. I'm not sure I will have dinged the gears. I've been particularly gentle, I feel. Well, I don't think I can improve that assembly, so that is what it is. New career as a hand model, that seems particularly unlikely. Right, so now we've got some wires going out one way and some wires going out t'other way. Those will go under here. Those will go under here. That's fine. Keep them over the top for now. That's secure. Da-ba-da-ba-da. Right. Where's that other? Here it is. And the fan. This is true that if you do tighten it misaligned, then it won't be in a great orientation, but I did try a few times there to get it in the right place, and if I can't get it in a few times, then I would suggest that it's not me that's the problem. "115 people according to my screen. Welcome everyone, especially anyone who's not been here before." How long have we been going? 32 minutes. 115 is a pretty good number, so maybe we'll do a... No, we'll leave the sponsor for maybe another 15 minutes or so. 15 minutes, and then we'll do a sponsor message. Get this fan back on. I don't know what I'm doing wrong with this. I think there's... It was assembled, but is it? Maybe it's that bridging issue again inside. Oh, there we go. That just, you get the right angle, it just seems to go in. Takes a little bit, but it's in there. Oh, there we go. Try not to overdo it, because those fans are quite brittle, so they can get crushed quite easily. What material to use for the printed parts? So the standard parts from Rackrig all come in PETG. My personal recommendation, if you're going to be enclosing it fully, would probably be to go with ABS to get a little bit more temperature resistance. In theory, the internal temperature probably won't get past maybe like 60 degrees-ish, so your PETG should be fine, but as you get a little bit closer to that 80 degrees-ish mark, they can tend to soften up a bit, especially over long periods of time. So I would probably go with ABS. ASA is obviously easier to print, and we talked a little bit about this in the last stream. And from my experience, the problem with ASA is that the layer bonding is just really, really bad, like incredibly bad. So for printed parts, especially where you're screwing into them and applying forces and maybe some irregular directions, they're just not really that great from my experience. Polycarbonate could be a really good option if you have the capability, or anything higher temperature if you have the capability, obviously. Of course, when printing ABS, you need to be a little bit careful with the fumes and such. So retracing all the steps for this. PL touch. Good, good, good. So this is where we start to get into the much more DIY territory of this build. So while it is a very thorough and complete kit, there is some knowledge required in order to complete it, or at least instructions from elsewhere. So particularly with the Duet, they have a lot of instructions, although they can be quite difficult to follow if you have trouble with some more technical language, but they're generally very good. So just take your time. But there is, when it comes to all the wiring, if you've not wired up a printer before, just take your time, maybe watch this, and I'll give you some pointers on how you can do it to the best of your ability, as they say. I don't know what to do next. There's so many things that kind of need to happen now, sort of at the same time. I want to start with the Duet configuration, but I can't finish that until, well, it's probably best not to finish it until we've done some configuration so we can test things moving around. I know what I wanted to do. Right, we're going to switch gears completely. Sort of completely. Mildly, completely-ish. So, who would like to see me do a little bit of CAD designing a clip for the cables on this? From what I've seen, although I didn't really look, the panel would seem logical, but I'm also terrified of doing it. I kind of want to do some clips, but we have to do some Fusion 360 CAD in order to do that. So who would like to watch a bit of that? It might be a little bit slower, and then we'll have a little cable management clip that we can use to help route some wires, particularly stepper motors around the bottom of the frame and such. So, not actually very prepared for doing Fusion 360. Right, let's try and get this set up. I hadn't taken into account that I would have to sign into Fusion 360. I don't have it on this computer. Oh, I've messed that up, haven't I? Maybe we won't do it today. Oh dear. Do I really not? I must do. Surely I do. What is the mass of the finished build? That's a good question. Quite difficult for me to check. I have kitchen scales, but they only go up 5 kilos. I do have some luggage scales. They might be more appropriate, although I'd have to hook them on somewhere and hope for the best. Yes, it's almost like I hid the view of the keyboard for a reason, isn't it? um, Just trying to sign into Fusion. I shall be just a couple of minutes. If I was clever, I'd have done this earlier. So, this is going to be interesting, isn't it? So, let's flip to this view for a second. So, the plan is I don't need the instructions at this point, but I do want to see chat still, ideally. So, let's stick that down there. Ah, yes. Simon, you are so on the ball. Yeah, let's have a quick 2-minute sponsor break while I try and set up the Fusion 360 interface and everything. And it's 2 minutes, so that'll give you a little bit of break of my voice while we sort that out. I shall be back in 1 minute, actually, and 55 seconds. This live stream would not have been possible without our sponsors, RatRig, Duet 3D and 3D Printz. The Duet 3 Mini 5 Plus balances value and performance. It's focused on small and medium-sized machines for those that want the quality and reliability of a Duet control board but don't want the high price or high power output of the full-size Duet 3 mainboard. The Mini 5 Plus provides 5 onboard drivers and the normal complement of heaters, fans, I/O, etc. There are Wi-Fi and Ethernet variants with the option of using a single board computer, like a Raspberry Pi, for control, in the same manner as you might with other Duet 3 boards. 3D Printz is a UK-based filament supplier, but in recent times have become so much more. They're now a great destination for finding name brand components from all over the world, such as the Anklab's BL Touch, Wham Bam Systems, flexible build plates, 3D Gloop, Magiku, Bondtech, Slice Engineering, and more. If you're in the UK and Europe, and maybe further afield too, you might want to check out their shop for your next printer upgrade. In the UK, you'll also be able to take advantage of their free shipping for orders over £50. RatRig is a company that you may not have heard of yet, but if you're into DIY 3D printers, or camera sliders, then we're going to change that today. The VCore 3 is a fully configurable CoreXY 3D printer kit. It's gone through several iterations over the years, and all the knowledge and lessons learned have been distilled into the VCore 3. MGN linear rails, low vibration idlers, robust 3030 extrusion frame, and 9mm belts are just some of the key selling points. Today, I'm looking at the 300mm cube default configuration, but it's also available in 400mm and 500mm cubes for those that like their printers big, and with lots of configuration options too. Keep watching to find out more, or if you need more details immediately, you can find the links in the video description. Right, there's even fewer cameras now. Cameras are slowly disappearing. Let's just transition to that one for a second. So I'm still trying to set up a decent view so we've got everything we need on screen. Hopefully you'll be able to see me, hear me, and everything. Yeah, you're probably going to struggle with the fast forward in a live stream. Traveling through time can be a little bit of a challenge, I've heard. Okay. So let's try this. Is that working? Can we all see that? Okay. So I'm going to bring my other camera in a little bit closer, and we'll use this as a bit of a face cam so I can talk to you a little bit while we're doing it. So this is going to be a a crash course in creating a small cable clip that we'll be printing off for the cable management. So hopefully you can see everything, and frame rate looks smooth and everything looks pretty good. So let me try and first make a little sketch to show what I want to try and achieve. It is something I've done before, so for a different printer, so hopefully it will be okay. So I know you can't see this. So if we just switch to maybe that for a sec. Oh, you're never going to see it. Trouble with sizing and pens and everything. So the idea is, obviously we've got the extrusion that looks a little bit like this, like that, and then you have the bit in the middle. So this is like one quadrant, if you like, one of the quarters of the extrusion, and we want to have cables that can be held approximately here. So what I want to do is basically create a single printed part that can do this operation. So obviously we need a part that's going to hold the clips, and that's going to have a clip sort of arrangement. So we're going to have that come over the top, and then from there we'll have a kind of T-nut shaped base that we can, oops, daisy, twist into place, and then that will come back out there. So it's this piece that we want to design. Hopefully that's sort of clear. You have some sort of idea what I'm trying to do. So that's what we're going to try and do. I'm going to grab some calipers and we'll get on with sketching. So we already know the, switching back to Fusion. So let's start by creating a sketch where we can have our extrusion. So I'm going to kind of draw part of the extrusion to begin with. So I just use the letter D to add a dimension. Click in the lines that you want a dimension and typing them in. We don't need to get too advanced with all the variables and stuff because we don't need that today. Let's just carry on with this sketch. So then we need to add where we have the slot. And we're also going to need the kind of width and depth here. I don't want to go overboard with the geometry. And to be honest, it's probably best to do some symmetry here. So I'm going to draw a line up the middle, trim these two, press X to convert that to construction, double click this one to select that chain, and then we'll use the mirror tool to mirror across this line to create the other half. So now we've got that, we can take some measurements of the extrusion. Unfortunately, I don't have a piece of the extrusion spare, so I'm going to have to turn around to measure it. So we've got 8mm width, 8.1 about. So this is, we'll stick in 8.1. The depth is going to be important, obviously. That's 9.1. Pretty sure I zeroed it. Zero enough. These are obviously 90 degrees to each other. I should just do a perpendicular mate. So if I click that one, control click the next one, and then where's my sketch tools for, this is weird. Why does it look super different? Is this like an old version or something? They're all over here. I think this might be an old version of Fusion for some reason. We're also going to need this step. This is going to be quite important to make sure the clip holds nicely. Extrusion wall is 2.2 millimeters. So is that the one I'm just about to need? I think that might be this one that I'm just about to need. I'm not sure the width of this is going to be hugely important, but we can stick in half of 2.2 here, and that gives us that. So this geometry is not super precise, but it should be enough to give us a guide for creating our design. So I'm actually going to stop that sketch. This is an old version of Fusion because all the buttons look different. I've obviously not updated this computer in quite a little while. So now we're going to create another sketch on this plane, and we're just going to do it over the top of this one. It just helps kind of shade that one into the background a little bit. So how are we going to do this? We're going to start with, I'm just going to try and do a bit of an outline actually, a bit of a lazy method. I think maybe something similar to the shape that's already there is probably quite good. And then that's going to come out this way. We'll use a 3-point arc, oops a daisy. This end, so I want it difficult to get out but easy to push in. So by having a kind of shape like that, as we push in we'll be pushing against the angle, but as they come out there'll be the flat face, so it shouldn't come out. And then we can just basically join back to the start. Oops, not like that. I've just remembered, I made the topic of this live stream wiring, didn't I? Well, there you go. I'll have to change that afterwards because this is not wiring. Apologies to anyone that was expecting wiring and got this. So, in terms of overall width, I think we probably want to make, I think it's not easy to dimension to that. So what we can do though is make it tangent. So tangent gives a this and a this, and that'll move that right up to that line there. So it doesn't go over. So in fact, change of plan. I'm going to do a slightly weird thing. So I'm going to make this, so that line is obviously tangent to this, and then I'm going to dimension this because I want a slight offset here. So if it's up against a panel, then we still have some wiggle room. So a couple of millimeters. In fact, then maybe let's just leave it to 1 millimeter. And I'm going to do about the same on this side too. Everything's going to look really thick at the moment, which is why that 2 millimeters looks big. From here to here, I think we want maybe 0.0, 0.1. And then here, I want that 0. So that's going to be, come on, collinear. to be collinear with that. Oh, come on. That's going to be collinear with that. We also need to make these two equal, so this side equal to that side. That's starting to look a bit better now. Yeah, I obviously have not used this computer for CAD in a huge amount of time, which kind of makes sense because I have better machines for doing CAD, and I don't think I've ever done CAD live before, so there you go. It's a new experience for everyone today. How do we want this to look? Let's get some more dimensions in. This to maybe 1.5. In fact, so if we're going to have 0.45 line width, I'm going to make it 0.45 times 3, I think, so 1.35. That starts to look a little bit more like what I'm expecting. And that's going to make this seem weird, so that's going to make that 2. We're going to change that to 2. Good, good, good. Things are starting to look a bit more normal. So this dimension in the middle is actually quite important because if I find a piece of paper, I need to do more sketching. Where's my... Here we go. Another tiny piece of paper. Let's just go back to the top-down one quickly. So if you imagine... I'll just use this. So as you put the hammer nut into the slot, you obviously have to put it in and twist it. But the way I'm going to lay these on the print bed, the thickness is obviously going to be determined by how thick I make it, and that is going to have to rotate. So we're going to have to make the height and the depth about the same, and then we can make a sort of circle or hexagon shape. So we obviously have the extrusion like this, and well, that's the slot in the extrusion. This is like the main extrusion, and this is the main extrusion. This is the slot in the middle. And then the cable clip will sit across it like this, with obviously the cables going in this direction, maybe something like that, and then out the other side, something like that, whatever, you know. So it's this down to here. It's going to be kind of important. So that's so here we can see this dimension here. T is going to be about the same as this dimension here, which is T. But we also want to have a hexagon shape because we want it to be nice and easy to print. Hexagon, octagon rather. So there's another terrible diagram of mine. Hopefully that explains the point. So I reckon we want this to be no more than about 7. And we also need to make sure it's, oh dear, it's symmetrical around that center line, because otherwise that's going to be weird. Hold it. Symmetric. Oh no, I selected them in the wrong order. It's left and right, and then the middle one. And then we do symmetric. There we go. Bring this in a little bit. That doesn't need to be anything like as wide. Make that perpendicular to that. So this can be maybe 0.1 from here. No, 0.1. There we go. In fact, let's make it 0.2 just because we don't want them binding as it prints. In fact, no, change my mind. 0.1, and we'll put a fillet on it because that'll be nice. In fact, we're going to have a bit of a rad on there from the print anyway. And I think that's starting to look quite good. Let's get an angle here of say 45 degrees. I think we might need to scrap that angle. I think we'd need to dimension this instead. Hang on, we have this dimension to play with too. So let's make this maybe 3 on the inside. Maybe, yes. And make this maybe 3. Make that 35 degrees instead of 45. And I'm actually going to bring the whole sides in, I think. Oh, that's weird. That 3. And where's this side gone? 3. So now if we take this sketch and we make it 7mm that way, we now have something that looks like a clip. Oh man. Oh, the sketch you couldn't see. Okay. This is what the sketch looked like. Apologies for messing that up. Basically, that sketch came from this being the extrusion slot. You have that bit down the middle. This is like, so this would be your 30 across here. And then you've got the clip that goes across the middle that we've just drawn. Obviously that's going in the opposite direction, so you've got your cables going that direction in here. And obviously this dimension here has to be the same as this dimension here, because this has to be able to rotate in here. So we say that's T and we call that T. And then we know that this, the thickness of the clamp has to be basically less than the extrusion slot width. Now let's transition back to the CAD. Oh, no. So what we do need to be careful of, I remember doing this before now. So I'm going to go back to the top down again quickly. The critical one is actually the diagonal, because when you have, obviously during that rotation, a square will be at its widest when it's at 45 degrees. So we need to make sure that the cross flats here is basically less, well, any points need to be less than 8. So there to there at the moment is 9.8. So if we add some fillets, where's fillets in this old version? Oh, chamfer, I mean. 1, 2, 3, 4. Why's that sketch gone weird? Did that look like that a second ago? No, it didn't. Why is that? Oh, it must be selected. Yeah, that's strange. Okay. So what I'm going to do is do a inspection section down here. And we're going to do a sketch on this hexagon. Oh, hang on. I did the bad thing. Make that symmetrical. Total of 7. There we go. So creating a sketch on that plane, the XY plane, and sketching a circle just to make sure everything's going to be within the 8mm allowance. There you go, so that's how it's going to rotate. That's the circle and that's the hexagon. So you can see all the points. Oh, damn it. Sorry. I'm super out. This is why I've not done CAD live before. So So I need to go back. So what I did was add in some chamfers, and then I accidentally had one here, so I took that off. I then inserted a section view, which you can do from Inspect Section Analysis. I then moved the extrusion to be on the neutral plane, and then top-down view and a sketch of 8 to match, because 8 is the slot width. And now, yeah, sorry about this. So hopefully that's clear of why those dimensions are what they are. That hexagon should rotate nicely in the extrusion, and it will also mean that we can print it with the nice 45-degree overhangs on the side. So we can now hide that analysis. So we do have to be a little bit careful, because obviously these little lines here are going to be quite thin for printing, but it's going to be quite short, so hopefully we don't have much risk of any too serious, what's the word I'm looking for? Curling, warping, that's the one. So I'm going to make this a little bit wider, not too much wider, just to make sure we get some close contact in there, and I think that's looking pretty good. What I suppose we could do, so the way it's set up like this, obviously I've put these chamfers on all 4 corners of this part in the middle. You could only do it on 2, and that way you could control the way it rotates, just like a hammer nut. But because we're not trying to screw in kind of invisibly, we've got access to this from the outside. I've basically tried to set up the geometry here, so when it's printed, it will be a little bit thicker than it should. And so as you turn it into the extrusion, it will just kind of cause this kind of part across here to bend a very, very tiny amount, and that will just give it enough clamping force to hold it into place. So we might have to fiddle the geometry a little bit after the first one, but I think we should be okay. I'm going to just make it look a little bit prettier with a couple of modifications to the sketches. Not that one. Oops. So what I do want to do is add a fillet in, where has it gone? Sketch fillet, please. There we go. There you go. Now you can see how far that's actually going to come down. So we want it to be kind of like that. That's probably better. And then we can make this up to 45. And then maybe make this up to 4. I think that looks cool. And then I'm also going to put an actual fillet in here. Make sure you do the same thing for the hammer nut parts. Your clearance there is 16.5. I'm not sure what you mean. So I know regarding the question there, add some fillets on the sharp corners, 3D printing guru. So yes, obviously you can. Let me do it as an example. So for example, here, 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 here. But let me show you, like, so the line width, the nozzle diameter, kind of line drawing width, is going to be 0.445. So even if we keep them completely sharp, they're going to come out like this anyway, because you can't draw anything finer than that. So if we made it up to, say, 1 millimeter, we could do that. Starts to look a little bit weird there, but it looks quite nice down here. Maybe we could do the 1 millimeter on those, but this is just, for me, not really worth doing. I'd rather just leave it as it is. So this is what, 7 millimeters wide. What do we think? Obviously the spring stiffness of that plastic could be a bit debatable. Not exactly sure how that's going to turn out. The overall width of the hammer nut part must not exceed 16.5 millimeters. Ah, yes. I did the same thing before. Ah, how did I do it? I remember. Same diagonal. Okay, so thank you very much for that. Yeah, having done this more than once, I should have remembered. So, what he's talking about, so as we did with the parts here, we obviously have that rotation, so we've got a limited clearance on the inside of the extrusion that we need to rotate through. And the same is going to be true here, obviously, where that nut is going to be inside the extrusion. At its diagonal, we've got a limit to how wide that can be. So again, we need to be careful of our limitations there. So 16.5 millimeters there, so we can do the same sort of section view, and we'll draw, in fact, we can just modify the sketch, and we'll stick in a circle for 16.5. It's weird not having a number pad. And we're going to show our analysis section, the section view, and we'll modify the dimensions of the section view to move it down to about here, the widest point of our current design. And would you look at that, like a glove. So as that rotates, that point will come out here, but it won't come up to the 16.5. So fortunately, because I stuck those fillets on, looks like we're going to fit just fine. I feel like my voice is starting to go dry because I've just been constantly yapping as I'm CADing. I'm actually surprised a little bit that the number of viewers has gone up. I kind of expected a few people to disappear when I start doing CAD, but it's been good, so I'm glad you have appreciated that. So unless anybody has any good ideas of things we might want to change before we go and print this. I think we can start warming up the printer and we'll get one printed. Johnny, you cannot anger the bot. The bot merely will just, it will just get rid of you immediately. Bot does not have any sense of humor whatsoever. If you put a few caps, that's it. You're going. All your messages deleted. So, be my guest, but yeah. The bot will literally just pretend that you never even existed. So, now we're going to make an STL. Before I actually do that, I just want to check what opens when I... Oh, please say this version allows for export of STL. Yes. Refinement, that'll be fine. Okay, just checking that it's not going to show stuff that I don't want it to show. So, because the interface is obviously a little bit different to what it is now, this won't look exactly how you would do it yourself, but if you right click, I think on newer versions you can right click a body and do it, or you can still do it here too. Excuse me. So you right click and click save as STL, which brings up this option at the side. The format you want is binary. I've never used ASCII, not sure why or how that would be a thing, but binary is what you want for 3D printing. Refinement basically tells you how many triangles it will produce. So high refinement will be loads of triangles and lots of data. whereas low refinement will be very few triangles. For very simple geometric shapes, largely like mine, low is probably enough. I'm going to use medium. High would be a little bit exuberant. If you're using high on really detailed and large models, you're going to end up with a huge file which will just slow down the whole process. But if you're doing something that is going to be very large at the end, I would use the high refinement, because as they scale up, you're going to see those large faces. So there you go, there's that. And then you can change your refinement options if you want better control. Then you just click OK and save it to a location of your choice. I have a stream data folder, so my rat rig cable clip is going in there. So now, oh, I've got this coming across and things all in the way. Sorry, I'm all over the shop. Now we need to print it. So we need to set up a slicer. So I'm going to be slicing on the Prusa Mark III just because it's literally right behind me. When you're doing a stream, the more accessible, the better. It is a bit noisy, unfortunately, so you'll probably... oh yes, ear cam. What about shiny forehead cam? There we go. What if we line it up just right with the rest of me? There we go, that fills in the gap. Oh, it's gone blurry. Anyway, I'm going to stop fiddling with that. So we want a slicer. Where's the slicer? Okay, so now we're in the slicer. We need to find our model and bring it in. So we've got downloads, we want desktop stream data, we've got our rat rig cable clip, and you can't see that window. So it's brought it in like this because I didn't necessarily model it in the required orientation for printing. To be honest, I rarely do now that the reorientation is so easy. So we click place on face, slap that down, and that's going to print it upside down. I'm going to print this at 0.2mm layers out of PETG. Infill is probably going to be largely irrelevant because it's only very thin. Oh, it looks like our line width is a little bit off. Let's go and increase line width to 0.45 in all the places. Where's that setting? Always forget. Oh, that should be exactly 3 lines. It doesn't look like it is. That looks like 2 paths there. Well, hopefully that's okay. Well, firstly, it's 30-30 extrusion, so yeah, so that wouldn't work. So, sorry, I'm just answering a guy printing's question who asked, why not use the DXF of the V slot or of whatever extrusion profile? And yes, if you have that to hand or very easily accessible, do that. But on a live stream, not necessarily the easiest thing to handle all of these things at once. So I'm just trying to keep it a little bit simple, and measuring is the easiest option. And to be honest, I quite like measuring on the basis that you are then really certain that that's actually what you have. Sometimes it can be, well, it can be very easy to find stuff online, find data, it's information, but it's not always 100% exactly the same. For example, there are different sizes of 2020 extrusion which have different size extrusion slots. Now in this case, it wouldn't be a massive waste if you did one clip and it wasn't perfect. That wouldn't be the end of the world. But preferably, personally, I like to check, at least verify the dimensions on exactly what I'm building, rather than just taking data sheets as verbatim. So let's export that to there. So we've got that quick export, and then we can use the quick remove device button. So good, those things. And that's going to go in the printer. We won't watch the print. We can start on something else now. Obviously, if you were doing it yourself, by all means, go and print like... Where's this gone weird? You can easily set up like 10 parts on the bed all at once. It's absolutely fine. But for the first design, double checking that everything fits and that kind of stuff, we're just going to do one for now. There's my terrible drawings out of the way. Right. I set the slicer to 2 parameters. Well, yeah, because it's 2 one side and 2 the other. So that's a total of 3. Because you can't do... It's going to be like that anyway. I think it's doing... I don't know quite what it's doing there, to be honest. It should be 3 across, because I did it at 0.5 times 3. And the wall thickness there should be 0.45. Everything apart from this and this 0.45. So I don't know why that's strange. Doesn't matter. We'll get it out and see what it's like. Shall we have a go with this back plate? This is just going to be a huge noisy mess. My neighbours are probably going to really dislike me because I'm going to use a jigsaw to cut this out. Or maybe I could just do the drilling. So let's readjust some cameras. That's going to be okay. Duet runs RepRap firmware, so when we get to that you'll see it's really very, very different. Some people prefer it, some people do not prefer it. Personally, I think it's very, very good. And it means you can change configuration without completely recompiling your firmware, which is rather useful. And you can set up all sorts of macros, and everything runs off G-code. It's pretty cool. So let's stop this. There we go. So, don't know if you can see this, or how well you can see this. If you look in the files and data section, I'm not exactly sure which section, but if you go to the project page for the rat rig, you'll find, well, definitely on the GitHub, all the geometry for the enclosure panel, which slots in there. So it kind of would be like sort of that, but in that portion there. Question is, do I try and snake a jigsaw up the middle or go straight across? Going straight across is going to be a bit of a pain, I think, because we've got power supply holes here and we've got Duet holes here. So maybe it would have to be right down here to do that. I think actually if you just cut this bottom off, it would also work. So maybe we'll just do that. That could be a... no, I'm not sure. You could... Still wouldn't be easy if you just did that. Probably should have spent a little bit more time thinking about this before the stream. So maybe we'll do this kind of S-shaped thing. 1, 2, 3, 4. So we have 2 on one side, 2 on the other. That gets you something reasonable. Yeah, clippers not something I've tried yet, so I do need to try. Probably I'll use the Duet for this, and maybe if I do a Voron, I think the battery's really low on this. If I do a Voron, I'll maybe use clipper for that. I'm pretty sure that's Ron's clipper, doesn't it? Let's start marking this out a little bit. That's the printer starting. I did have a scribe in here that I was using here, which is so. How am I going to do this? I will probably be trying both in the meantime, but obviously Duet's sponsoring this, so you know there's that. This material, by the way, is it's an aluminium composite called Bond. I think that might be a brand name, to be honest, but it's basically layers of thin aluminium sheet on the outside, and then there's a polymer in the middle. I'm not sure how that's gone so wrong. I lost my mark. There it is. How is this miles off? What have I done there? 30. That should be there. It's fine. So now I want to put some lines sort of across here, maybe where we can just roughly do. I'm trying to be wary of the fact that I've got to try and actually cut this with a lost the word, jigsaw. So anything that's too tight a corner just won't be possible. Maybe we'll do another diagonal here, and I'll be able to add another screw hole up there. Yeah, I guess price of this stuff will vary depending on where you get it. I got quite a few parts from an eBay seller, and I just asked them for offcuts. But this stuff is from like a standard 8 foot by whatever sheet, and they were like, yeah, we have some offcuts, and they were like this kind of size, and I had 100 of them. I was like, yeah, I'll just have some offcuts, and they charged me like £2 a piece or something. So obviously choose whatever material you can work with and get at a reasonable price. Entirely down to you. So I think I've got a plan. So I'm going to go here and then go this way, here and go this way, here and go this way, here and go this way, this way, this way, this way, this way. So it might look a little bit rough, but this will hopefully give me... Oh, the light's on above. If I turn that off, you might be able to see that a little bit better. I know there's just a lot of marks and you can't see all the detail that I can, but I've basically put marks where all the holes need to be and that kind of thing. So cut along there, holes in here, for example, tracing this line here for that. I didn't really mark this S shape. I don't think it's going to be hugely important as long as I've got something. Obviously I can add holes in, but largely that should be about what we're looking for. Yes, so the turns will be tricky. I might be sort of cutting the corner, or my other thought was getting a drill bit and pre-drilling holes in all the corners to kind of help that turning, because the blade is quite thick, so that could be problematic. I'm also not sure, I'm going to turn this light back on again because it gets quite dark otherwise. I'm not sure how well you're going to be able to see this process because I'm going to be cutting it off the back here. So I'll do my best to set up decent cameras so you can watch what's going on. And that's printed the wrong thing. Oh man. Maybe I'm not. Oh no. I thought it printed the thing from last time, but it hasn't. So let's see what we can set up in terms of camera angles. So that's going to be about there, and that allows you. So I'm going to cut this bottom edge off first. I think that's going to be the first job. Ooh, it's 9:05, so hopefully it's not going to be too loud for my neighbours. I do worry about that sometimes. I'll try and get it done reasonably quick, and apologise to them if I need to. So I'm hoping jigsaw off the back of the table here. Could maybe do it without this and you might have a slightly better view, but I think with it, it's going to hold this panel just a little bit more securely. Safety squints. So that should have not quite enough room. Need to find somewhere to plug this in that's going to be safe. I think over here. This is so noisy. Kind of wish it was closer in, it just flexes a bit over here, but... Oh, I remember what I was going to do. Apologies for the headphone users. I'm going to mute the audio while I'm doing this so that you don't have your ears blown out by large, loud, screechy sounds. So I'll mute it for a bit. Sorry about the previous attempt. Okay, so that went reasonably well. Obviously we've got some quite sharp edges. I'm hoping a deburring tool will make light work of that. Probably shouldn't have cleaned up until after the deburring. Apologies to those that wanted to hear the sound. Can't imagine why, but there you go. Yeah, you can hear the sound of the Hoover if you want. Warning for headphone users, loud sound starting now. Okay, so I think my nose is just a jigsaw. Yeah, I might get a bit of flack for that. Hopefully not. It was pretty loud though. I did think at the start, if I'm going to do it, it needs to be the first thing I do, and then I really wanted to do some CAD, so I did that instead. I don't make a habit of being a loud neighbour, so hopefully it's not a problem. If you do get this stuff, be really careful with this waste, because the very small bits of aluminium can be very, very sharp. So that panel is now looking like the right shape that we need. If I do need to cut off a little bit more from the sides, I can do that with a file. What I do want to do is kind of try and demonstrate why it needs to be cut. Because I see people questioning why I'm making such an effort over it. I might be wrong, to be fair, but we'll give it a go and see. Oh my goodness. Awkward. So, how much of this can you see? Let's just look at our angles. Right, workbench time. And then be sponsor time, I think. So this is the panel. It doesn't fit here. This is not the point of this particular panel. There is another panel that does do that, but that is not this panel. Have I got it right? This one goes... So you've got obviously the main back panel here, which you could put a panel on, but you need it and the next layer in up here where the cable management thing is. So in order to do that, you'd have to get this in there and also behind those stepper motors. And I don't believe that's physically possible. There's just no way of getting that in there where you need it. So that's why we need to cut it somehow to make that insertion possible. The alternative is doing this at the beginning and assembling it properly, but I didn't. So yes, we do now need to cut it. I'm really nervous about using the jigsaw, about how much noise it's going to make, because I really don't like being a noisy neighbour. What I maybe do, I think what we'll do now instead, I'm going to cut this, I think, camera in my head, during the day sometime, so we might miss the live stream for cutting this, because I'm aware I've probably pushed the limit already. That was a little bit louder than I had anticipated, to be honest. So at least you have an idea of what to do. You probably wouldn't have to do this bit up the middle either yourself, because you will have done it in advance. So what I'm going to do instead is start drilling, which we can do because drilling is quite quiet, especially in this very easy, soft material. So we've got a thick waste board here that I'm going to put this on top of, so I don't drill into the desk, because that would be bad. And then hopefully we can just sit it on here, easy peasy, clamp down from the two sides, and we're good to go. Cool. So in preparation for this, although the metal is soft, I have used a center punch. So let me just show you what that process is. There are a The type of center punch you can get. The one I have here is literally just a solid piece of metal. It's quite thick and it's got a sharp point. Typically you do this on hard metals where finding the center, well, basically the drill will wander, as in the tip will just kind of do this across the surface if it doesn't find a low point to kind of sink into. Sorry, just getting bits of waste stuff out of the way. So what you do is create an indent at the point where you want to drill just by tapping it, and it leaves an indent, which means as the drill gets to there, or you place the drill on there and start drilling, it will naturally locate into that hole. So it stops the drill wandering. Obviously the downside is you need to be careful where you place that punch, because otherwise you end up with it in the wrong place. So now let's drill a bunch of different holes. So there are loads of different holes required. I've marked mine as M5, M3, etc. The M5 holes, I'm going to be drilling mine at 5.5 millimeters, because that's the general normal tolerance for a M5 hole. That'll mean I get a little bit of wiggle room to make sure, where are my drill bits? To make sure everything fits. The 3mm ones, the M3 ones rather, will be 3.5. The M4 ones will be 4.5. And this hole, which is for cables to come through, is marked on the drawing as 16 millimeters. I don't think I have a 16mm drill bit, so we might have to get a little bit creative with that one. Maybe like drill 4 holes and use a, I don't know, something to cut out the middle. .5 for M5 is not too big. That is normal tolerance for my industry. It's 1/2 mil, that's 1/4 mil on either side. That is not too big. What do you mean all I've done? How rude. I think you'll find, what? I designed a thing. Speaking of, it's finished. So this is the little thing. I could have made it a little bit thicker, to be honest. It's quite small. So we've got this little bracket that we've designed. So obviously it opens at the side. That spring stiffness is quite good. Oh, it's gone blurry. We're doing so well. The question is, does it work? It's a bit loose. Damn it. So this, it rotates into place really nicely, but there's just a touch of wiggle room. I do like the clamping. In fact, before we do this, we'll make our second version of the clamp, and then we can get the second version going while we're doing other things. So before we do that, so we need to go, we were on the slicer, we need to change this to this. Don't need that. Now we should be able to see this, but we can't for some reason. Huh? I could add little dimples. So let's transition over to the slicer. So the issue we have is that this gap here is a little bit too wide. So I was expecting some over thickness, which is why I made it 0.1 clearance and nothing less. But let's measure what it's come out as roughly. I mean, this is saying 2 millimeters. So I think we may have had some false information regarding the thickness of that top lift on the extrusion. So that's 2 mil. And even though this says 2.3, so it did come undersized as planned, but not undersized enough. This is where a DXF might have been useful. And another one bites the dust. Another one bites the dust. Streamlabs bot goes overkill yet again. So there are a few things. Do we want dimples? I'm tempted to just make it a little bit thicker. So I want to make a couple of changes. Now that I'm looking at it, I think the area where the cables go could be a little bit wider. I think 3 mil is too narrow. I want this to be more like 5. Beautiful. Nice and easy. I think, or do I want 4? No, 5's going to be good. It didn't react to the, oh yeah, it did react to the username. Yeah, because it's just caps, yeah. I did have a look at the bot and trying to reduce how much it impacts it, but didn't get very far, to be honest. So I think if we take that to 0, well, it needs to be coincident, you can't have a dimension of 0. Oopsie daisy. Take that, make that coincident with that. Collinear. And then we'll try some dimples. So I'm not very good at dimples. How do we do them? We'll probably revolve a shape. That's probably the best way to do it, isn't it? Oh, this is not... God, dimples are making my head go crazy. Let's so we want probably a sketch on here. Then we're going to draw half a dimple. Oh, not like that. I want a 3-point arc. What's going on here? I think we need to make that tangent to that and then that perpendicular. But we only want this protruding like maybe 0.1 millimeters. Something like that. That's, I think, locked to the center point of that line, which is not ideal, but there you go. We can then revolve this shape around here. That'll create a dimple. It's very slight, but it should help. So we should be able to also then pattern that feature. So we can do a rectangular pattern, do the feature, select the feature, select the direction. I like to select the axes for directions, do that. We only need 2, thank you. And that will do the same thing on the other side. We could mirror it as well, that would be another way to do it. Is anyone else only getting 1440p? It should be at 1080p. Okay. Sorry, Brandon. Seems to be nothing I can do about it, I'm afraid. So, do you want 0.1 or do we want a bit more? 0.15. That could be a bit too much. Oh, it's so difficult to know without having it physically, doing it. So we're just going to give it a go. That's that. Let's bring this in, I think, a little bit like so. And I think we're also going to add this fillet over here now. And maybe here too. That looks kind of weird. Still looks kind of weird, but I think it's a good kind of weird. I think the rest of that looks pretty good. I need a drink. If anyone hasn't left a like yet, feel free to do so, and or subscribe. Right, so again, we're going to export the STL. In fact, it's already saved. Save an STL. And, oh, by the way, if you save it as this, if you save as from the body, it calls it body 1. But if you do it from the name of your file, then you get the version number in the name by default. Just makes saving a little bit quicker. So let's jump back over to the slicer. We'll delete that one, bring in the new one, lay it flat, same as we did before. Looks good. You can see those little dimples. Let's look at the layer view. You can see how there's just a very slight protrusion there. Glorious. Let's give that a go. So, same as before. Insert the SD card, export file, give it to the printer. I guess with mobile, are you running it off Wi-Fi? Are you running it off the like 4G or 5G? Because if it's a limited connection, it might be throttling it deliberately so it doesn't use all of your available data. Export to the SD card. Rat clip version 3 and remove device. Okay. Cable clip version 2 is on the way. Well, it's technically sort of version 3, isn't it? Because it says version 3, but it's the second version that's printed. Right, where were we? Doing some drilling. Can we see this? No, let's get to an angle we can actually see what's going on. Don't know what's going to be best. That. Second version of the third revision of the first design. There we go, very simple. Doesn't have to be fast, nice and easy. We can test it with an M5 screw. There might even be one in the box still. I think these are M5. They look like M4 or M6. Oh, I've got a 4.5mm drill. How have I managed that? So this is the back plate for anyone that's catching up. Getting a bit of lifting there because I've not clamped all the sides, but it'll be fine, I think. So let's get that screw back. We should have a decent fit for an M5 screw now. Perfect. Plenty of wiggle room. So there's no aches with getting screws in and out of the holes. So just for reference, as it's lifting, that's not a good thing. You should clamp your work so that doesn't happen. But on this workbench where I'm a bit limited for space and camera angles and all that sort of nonsense, I'm just putting up with what I can manage in this scenario. Ooh, that was the desk. That was the desk. Oopsie daisy. Can't see what you're doing. Is this, yeah. I don't know what's going to be the best. Oh, yeah. Sorry. This stupid transition thing, it didn't transition. You can't really see that either. Oh, that's useless. Then we've got nothing for the third quadrant. Without instructions, it's just weird. There you go. Maybe that's okay for now. That's the desk again. Looks like my backing board is not quite as useful as I thought it would be. Just as well, it's a wooden desk and designed for this. You can put idle on your drill bit for depth, or you can just put a stop on it. There are things designed to do that. Oh, you mean just because it fits over, because it's like a 5mm shaft or whatever? 20 points, so yeah, 10 points for each time I hit the desk. Oh dear. So that looks like all the M5 holes. Oh no, I've missed one. Over here. Now we need some. Now we do need the 4.5mm that I had originally for all the M4 holes. 4.5. Ah, yeah, drainage holes in the desk. That's a good excuse, that one. Oh, honestly, I didn't accidentally drill through the desk. I was just adding some drainage holes for when I, you know, make a spillage. I've lost chat. CNC router. Yeah, if I had something like that, it could be a method, but it's not something I currently have access to. Maybe in the future. So we've got some M3 holes here to do as well. I've got to find somehow to do that 16mm one. That's going to be a nightmare. We've only got 20 minutes left, so I think we'll give this a bit of a test fit. Hopefully that will come out perfectly this time, and then we'll be there. All right. Warning for headphone users or anyone with loud stuff, whatever. Going to use a Hoover to clear this mess up. 3, 2, 1, now. If you're patient, you can open a hole to 19mm with a deburring tool. I'm not sure I'm that patient. I think I'm going to leave it for now. maybe I'll find an alternative method. Let's give these a bit of a deburr. Oh, this is not easy. I think my deburring tool might be a little bit blunt. I'd rather use a drill bit for this, to be honest. I wonder if I can do it here. I think that's mostly there. Being careful, of course. So let's just check all these holes. Another one. This one. This one. Here. Yes. 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 And yes. Those the M5 ones all fit. M3 holes, 1, 2, 3, 4. Must have some M4 screws because we need to fix the power supply onto the thing. These M4 holes. Maybe not though. Am I being blind? Spare. Maybe in here. Didn't we find some M4 screws earlier? No. Maybe? That one looks like M5. What I wanted to try was the Duet. Here we go. Got a bit of oozy plastic this time. Didn't clean the nozzle. Right, let's show you this. So maybe I should show them side by side. Come on, camera. So you can see the top one is obviously the one that we did first. The second one is the revision. So you can see that top half to hold the cables is quite a bit larger there. Let's give it a go on the frame to see if it's going to fit nicely. That's crack-a-lacking. Doesn't move at all, but can be rotated out. Nice clip. I know you probably can't see very well from all the way back there. You have to take my word for it. It fits perfectly. Or maybe I'll move the printer across to the desk so you can get a nice, good, close look at how that works. How long we got? We've got 12 minutes. So let's first... So this is the Duet 3 Mini 5 Plus. I'm assuming these PTFE looking spacers or nylon spacers are designed to isolate from between the electronics and the thing. So we're going to have a go by eye. That looks good, looks good, good. Should be able to get those down there. Find some screws that we can poke through those holes. There you go. I don't know if that's correct orientation, maybe it's better the other way up, but hole pattern's the same, so that's good. Now we know that that fits nicely onto there. Obviously that's not screwed down, but we check the hole spacing and we know everything's going to fit for that. So that's really good. Success. Get that back in there. Keep it safe. Last thing I want is to damage that. Get that out of the way. I've lost chat, I'm afraid. Well, as in it's still there, but I have no idea where I got to. If nobody tags me, I probably won't answer because it's really difficult to follow when I'm not looking at it the whole time. Apologies. Let's stick that down there. Very happy with how that's turning out so far. So that's kind of just goes to show you don't have to get something all pre-cut. You can just find a panel and DIY it. So loud noise again, gonna hoover up some mess. 3, 2, 1. My favourite part, lifting the printer. Right. So if we look up at the frame up here, please focus. Here, please. Thank you very much, please. come on. So this was the first clip. As you can see, it sits in there but can slide up and down, so that's not really any good because it's not going to manage the cables, especially, obviously when it's sitting on the horizontal it kind of looks okay, but if you put it on something vertical, over time it's guaranteed to slip down. So the second one, obviously a bit thicker, starts to get some resistance, and there you go. That holds in really nice and snugly, very snugly, in fact almost too snugly, but it does hold really nicely actually. Very happy with how that turned out, and that's a decent clip sort of strength for adding cables in. If we grab one of these, there you go, that's a stepper motor cable, and yeah, by design obviously it doesn't come out very easily. You do have to kind of lift up to get past that clip, but nice and easy to push in. It actually comes out quite easily as well, but I'm not sure that's going to be a problem, so that's fine. It does. Yes, Kenneth, it does. Well, that is the desk that I just moved it off at the back, the workbench. This is the workbench. The challenge might be if you have the filament enclosure up the top. So the filament enclosure up there that you can't see, and you can't see my face now either. Obviously that filament comes out quite near the back, and the whole carriage moves here, so you're going to be feeding to a really large location, so it can be difficult, but we'll see. I've not tested it yet, obviously, because I've not finished building it. Right, let's move this back out of the way and we'll finish off. Oh, I forgot to do another sponsor thing. Let's do a sponsor thing while I move this out of the way. It's 2 minutes and then we'll be back for some conclusions and wrapping up. This live stream would not have been possible without our sponsors, RatRig, Duet 3D and 3D Printz. The Duet 3 Mini 5 Plus balances value and performance. It's focused on small and medium-sized machines for those that want the quality and reliability of a Duet control board, but don't want the high price or high power output of the full-size Duet 3 mainboard. The Mini 5 Plus provides 5 onboard drivers and the normal complement of heaters, fans, I/O, etc. There are Wi-Fi and Ethernet variants with the option of using a single board computer, like a Raspberry Pi, for control, in the same manner as you might with other Duet 3 boards. 3D Printz is a UK-based filament supplier, but in recent times have become so much more. They're now a great destination for finding name brand components from all over the world, such as the Anklab's BL Touch, Wham Bam Systems, flexible build plates, 3D Gloop, Magiku, Bondtech, Slice Engineering and more. If you're in the UK and Europe, and maybe further afield too, you might want to check out their shop for your next printer upgrade. In the UK, you'll also be able to take advantage of their free shipping for orders over £50. RatRig is a company that you may not have heard of yet, but if you're into DIY 3D printers, or camera sliders, then we're going to change that today. The VCore 3 is a fully configurable CoreXY 3D printer kit. It's gone through several iterations over the years, and all the knowledge and lessons learned have been distilled into the VCore 3. MGN linear rails, low vibration idlers, robust 3030 extrusion frame and 9mm belts are just some of the key selling points. Today I'm looking at the 300mm cube default configuration, but it's also available in 400mm and 500mm cubes for those that like their printers big, and with lots of configuration options too. Keep watching to find out more, or if you need more details immediately, you can find the links in the video description. Right. That was quite good in the end, wasn't it? It was a little bit disorganized, but it turned out exactly perfect. We designed a little cable clip for organizing the cables, which we can get started with now. Now that we've got a way to hold them, they won't just dangle all over the place. And of course, we sort of did a lot of the panel. If you were assembling that into the printer at the start, that would be all you need to do. The hill, cutting to shape and drilling all those holes. So quite a simple process if that's the way you want to do it. Now it's just down to you to decide whether I either planned it to be exactly that amount of time to do those two jobs perfectly, or it was just total luck. We did give the desk some holes, but I think the desk actually fared quite well. The drill did hit the table, so I did claim my 20 points. But I also don't seem to have permanently damaged it. But there's plenty of damage on it, don't worry. Especially from when I've, like, yes, hit things. When you see the reflection of the light, you can see quite how much it's damaged. But a nice wooden table deserves a good bit of damage to show it's been used well. So, closing 2 minutes. Don't forget to leave a like and subscribe. If you've watched the whole thing, then you probably don't want to miss the next one. We will be going all the way through this, and it sounds like everyone that I've asked so far wants all the details possible. So we will be doing as many details here as we physically can, just to make sure anyone that wants to buy one and is looking through how to do that, you have all the information you need. If you do want to buy one, of course, there's a link in the description below that will give you 25 euros off. So that would be fantastic. And it also lets them know that I sent you, so I get a small kickback from that as well. So I would very much appreciate it if you do wish to purchase, that you do use that voucher code. Of course, you get money off, so why would you not? Anyway, I think that's pretty much it for today. Unless anyone has any quick questions that you want to fire my way before we finish. I've got about 60 seconds. I think that's pretty much it, isn't it? I'm quite happy with how that went. I'll let you know if I had to apologise to my neighbours for the obscene noise late at night. And I'll try and cut that maybe during the day tomorrow. I think it's a bank holiday tomorrow in the UK, isn't it? I actually don't know. If it is, then we'll maybe doing live stream again tomorrow. So we may be back within 24 hours. Wouldn't that be fantastic? Cool. Well, thank you everyone for sticking around and watching. It's been great to have you here. Hopefully it's been useful for anyone following along or those that are just interested in looking to maybe purchase one of their own. Yeah, I shall see you in the next one. Maybe tomorrow, maybe not. Hopefully tomorrow. That would be pretty cool, wouldn't it? Right. Okie dokie. Bye for now. Where's the button? I've lost the button. That's next Monday. Okay, it won't be tomorrow. The bank holiday is next Monday. Thought I had a bank holiday coming. Anyway, I'm saying goodbye. Goodbye is so difficult.